Is 8C, and we are working on the episode number 4. This is the course book of the Pure Maths 1. The maths is 9709. We are on the question number 10 of this exercise. The exercise is related with the practical maximum and minimum problems. The chapter is related with the further differentiation. So we are working on the question number 10. In the question number 10, you see they have given you this question. Can you see this question? I hope this is clear. So the question number 10 is showing up on your screen. And so I have already solved it. So question number 10, the first part, they say the diagram shows a window from a rectangle with the base 2r meter and the height h meter and a semicircle of the radius r meter. The perimeter of the window is 5 meter and the area is a meter square. Express the h in terms of the r. Okay, the perimeter of this window is already given to us, that is 5 meter. So what we will do, the perimeter will be this side plus this side plus this side, and this is the arc of the semicircle. So the perimeter is 5 meters. So the height plus height, h plus 2r plus the arc of the semicircle will be 2 pi r by 2 is equals to 5. So you will have 2h plus 2r, and this 2 cancel. So you will have pi r, and that will be equals to 5. So bring these two to this side, and so 2h will be equals to 5 minus 2r minus pi r. So h will be equals to 5 minus 2r minus pi r divided by the 2. So this is how you will do the A part. Very simple and straightforward. And then they say show that the area is 5r minus 2r square minus 1 by 2 pi r square. If you want to find out the area of this window, the area of this window will be the area of this rectangle plus the area of this semicircle. The area of this rectangle will be h into the 2r, length into the width, and the area of the semicircle is pi r square by 2. So you will have, then I substituted the value of the h here. So 2r into the h is 5 minus 2r minus pi divided by 2, and y and plus pi r square by 2. Okay, so 2 cancel. So you will have r will multiply here. So you will have 5r minus 2r square minus pi r square plus pi r square by 2. So you will have 5r minus 2r square. These two with each other. So you are left with minus pi r square by 2. So now I know the expression for the area of that window. Then they ask us to find out its first derivative. So if you want to find out the first derivative of this thing, so you will have, when you take the derivative, 5r's derivative is 5, minus 2r square's derivative will be 2 into r, minus, and the derivative of the pi r square by 2, pi by 2 into r. So you will, your first derivative will be 5 minus 4r minus pi r. Then they ask us to find the second derivative. So this is my first derivative. If you want to find out the second derivative, okay, so d square a by dr square is equals to, derivative of the 5 will be 0, derivative of the minus 4 r will be minus 4, and derivative of the minus pi r will be minus pi. So d square a by dr square will be equals to minus 4 minus pi. Then he says at the stationary point, then we have r for which this has a stationary point. You know, when we find the stationary point, the dA by dr should be, the first derivative should be 0. So we will make this 0. 5 minus 4r minus pi r equals to 0. So minus 4r minus pi r equals to minus 5. So minus cancel. So r will be equals to 5 divided by 4 plus 5. So this, at this value of the r, that will have a, at this value of the r, the area will have the stationary point. And then we have to decide that whether this is a maximum point or a minimum point. For that purpose, I will take my second derivative. Second derivative is minus 4 minus pi. It does not involve r, and its value is 100% negative. So because the second derivative's value is negative, that means this is our maximum point. Okay. Now they want us to find out the maximum area. So what we will do, we will write the formula for the area, 5r minus 2r square minus pi r square by 2. and I will put the value of the R, this value will be substituted here. So 5, I've substituted the value of the R, okay. Then I simplified it a little bit, 25. This becomes 25 into 250. This becomes 25 pi by 2, this, okay. Then what we will do, we will take the LCM here. So the LCM here will be 2 into the 4 plus pi square. So when you divide this with this, you are left with the 2 and 4 plus pi. So that multiply with this 25. When you divide this with this, you are left with 2. 2 will multiply with the 50, okay. So when you divide this LCM with this denominator, the whole thing will be cancelled. You are left with 25 pi. So you will have here 250 pi minus 100 minus 25 pi. So it will be 100 plus 25 pi divided 2 into 4 plus pi whole square. So you can take 25 common. So 25 common. So you're left with 4 plus pi. In the denominator, you have 4. 2 into the 4 plus pi whole square. So this and this will be cancelled. So you are left with 25 divided by the 2, and its square is gone. So 4 plus pi. So it will be 25 divided by the 8 plus 2 pi. That is the answer, sir. And this is how you do the question number 10. I have already solved it, and I hope that this is clear to you. So let's do the next one. Here we have, the next one is a big question. We have the question number 11. So let's do the question number now. Question number 11. So this exercise which we are doing is exercise 8C, and this is subtopic of the main topic of this exercise is the practical maximum and minimum problems. These are story sums, and what we want to do is we want to do those story sums. And the main topic of the chapter 8 is further differentiation. So the whiteboard I have is the sticker one. So to clear the written work from here is a bit of a thing. Okay, so let me show you the question. Okay, so here we have the question number 11. A piece of wire of length 100 centimeter is cut into 2 pieces. One piece is bent to make a square of the side x, and the other is bent to make a circle of radius r. The total area enclosed by the two shapes is A. Express r in terms of x. Okay, so what we will do, what we are going to do, we have a wire. Try to understand this story, okay? So question number 11. So we have a wire, and this wire is 100 meter long. So what they did, they cut 2 pieces, and so they cut it into 2 pieces. Okay, so this is 4x, and obviously this is 100 minus 4x. Okay, so they made 2 pieces. One piece is 4x, and the other piece obviously will be 100 minus 4x. So with this piece, they made a square. And each side of this square is x. This is given. From here, I got that idea that the total parameter of that square is 4x, and from 100 we will subtract that. Then So what we will do, we will make with the rest of the piece, we made a circle, and the circle has a radius r. The perimeter of that circle, the perimeter of this circle, okay, will be 2 pi r, and that will be equals to 100 minus 4x. So I can say that the radius will be 100 minus 4x divided by the 2 pi. So it will be 50 minus 2x divided by the pi. Okay. Perimeter of that circle will be equals to the remaining portion of that thing. Okay, then they say his question is a part express r in terms of the x, which I have done. So 50 minus 2x divided by pi, that is how you represent the r. And then we will then in the next part he says that show that the area of this both the shapes together is this he has given us. Okay, so area will be the total area of these two shapes. The area of this thing will be A1 plus the area 2. So the area will be, its area will be x and its square. The area of this shape will be pi r square. So the area will be x square. This area will be pi, and this is 50 minus 2x divided by the pi and its whole square. So the area of the square plus the area of that circle. So that is the area of the both the things, okay, together. The total area is equal to the A. So what I have to show, then they have opened it. Okay, so let us also open it. So the area will be equals to, this will become x square plus, here you will have pi into, this is I think so sorry. So if you open it, you see the thing which to show, and okay, so we will open it. This, if you open this whole square, this will be 25 100 minus 100 102s are 200 x plus 4x square divided by pi square. Okay, so we will have a plus pi will go on, 2500 minus 200x plus 4x square divided by the pi. You see, I have opened that whole square. Okay, so that pi and the pi square, they have been cancelled. Now I can take the LCM, and the LCM, now this thing will become pi x square plus 2500 minus 200x plus 4x square divided by the pi. Okay, now the terms which have the x square, there are two terms which have x square. You can bring them together, and you can take their x square common. So you will have area equals to pi plus 4 into x square minus 200x plus 2500 divided by the pi. So this is the area of those two shapes. And the answer is right, sir. Then he says find the C part. Find the value of the x for which A has a stationary value and determine the nature and the magnitude of this stationary value. So what we have to find out is we have to find out the stationary point. So what I will do, okay. So we have to finding the stationary point, you have to derivate this, and we can derivate it easily. Okay. So let me say that let me take here dA by the dx. Okay, that will be equals to. So this 1 by pi. So 1 by pi will remain as it is. So this will be pi plus 4 into 2 into x minus 200, and the derivative of the 2500 will be 0, so no need to write it. Okay, you see this will remain as it is. The 2 will come on the side, the x minus 200. 200x derivative is 200. This derivative is 0, so I am not writing that. Okay, 1 by pi I have taken already outside. So the first derivative is you can write it like this. dA by dx is equals to 1 by pi into this is pi plus 4 into 2x and minus 200. Okay, so you can put a bracket around here. So when you have your stationary point, you know the dy by dA by dx will be equal to 0. So at the stationary point, the the dA by the dx will be equal to 0. So just make this whole thing equal to 0. So pi plus 4 into 2x minus 200 to 0. Either the 1 by pi is equal to 0, it means nothing. Okay. So pi plus 4 into 2x is equals to 0. So you will have 2x equals to 200 divided by pi plus 4. So this 2 will cancel. So you will have 100 divided by pi plus 4. So at the stationary point, the value of the x will be 100 divided by pi plus 4. So which is the right answer? So then what we will do, now I know the x value at which we have the stationary point. Now I have to find out the nature of that stationary point. For that purpose, we have to take the second derivative. So I can easily find the second derivative. You know, the dA by the dx is equals to this is 1 by pi into this is pi plus 4 into 2x minus 200. So I will find its second derivative, that is d square I by the dx square. That will be 1 by pi will remain as it is. Its derivative will be pi plus 4. This is a number, okay? 2x derivative is 2. Its derivative is 0. No need to write this, okay? So my d square a by the dx square will be equals to this is 2 into pi plus 4 divided by the pi. Okay, you can see the pi is a positive number, 4 is a positive number, 2 is a positive number. So it does not involve x. So that means it's a positive number, okay? So it means it's a minimum. It's a minimum point. So I know the value of the x. Where is the value of the x? This is the value of the x. Now I can find that minimum value of the area. The minimum value of the area is We have to find out the minimum. Let me check if we have to find out the determine the magnitude and nature of this stationary value. Okay. So we have to find out the we can if you want to make this things similar simpler, I mean, we can find out its value here. You can use your calculator. You see the value of the x can be found in the decimals as well. So 100 divided by bracket pi plus 4 bracket close equals to, it is 14.0. This x value, the stationary 14.0. So I can put this x value, where's the area? Here. Okay. So the minimum value of the area will be, this is pi plus 4 into the 14 and its square minus 200 into 14 and plus 2500 and the whole thing divided by the pi. I'm going to get directly its answer, sir, on the calculator. Okay. So I checked the answer and they have used the decimal value, so that makes the thing very, very easy. I just have to write this numerator. So it is 14 square multiply bracket start and it's pi plus 4 bracket close. Then you have minus 200 14. Then you have plus 2500 equals to, I got the answer of the numerator and then divided by the pi and equals to, this is 350. So the minimum area will be 350 unit square. So they were using the unit of 350 is the right answer and this is the minimum area, sir. So my dear students, we are doing the exercise 8C and this is the episode number 4 on this exercise, and we are doing the course book of the Pure Maths 1. This is paper 1 of the Cambridge International ASA Levels Mathematics 9709. So in this video, up till now, we have done the question number 10 and the question number 11. And now we will go to the question number 12. So I hope you have understood this question. I hope you have understood this question. Now we will go to the next question. The next question is question number 12. Okay, so let me erase this. The topic of this exercise is practical maximum and minimum problems. The topic of this chapter, chapter number 8, is further differentiation. Okay, so there are 2 chapters in this course book on differentiation, the chapter number 7 and the chapter number 8. We have already completed chapter number 7 and I'm working on the chapter number 8. So I hope that this will be helpful to you. For those students who are preparing for their AS Maths paper 1, this video can be very, very helpful, I hope. Okay, so now we are going to do the next question. The next question coming up on your screen is question number 12. He says a solid cylinder has a radius. Let me show you the question. Here we go. Question number 12. A solid cylinder has a radius r centimeter and height h centimeter. The volume of this cylinder is 432 pi centimeter cube and the surface area is A. Express the h in terms of r. Okay. Show that the area is this. Find the value. Okay, so we can easily do this. Okay, so we have the question number 12. And he says we are talking about they are talking about a cylinder. Okay, the a cylinder has a radius r. Its radius is r, and the height is h. And he says the volume of the cylinder is given. That is 432 pi centimeter cube. So you have a cylinder whose radius is r and the height is h. The volume of this cylinder is 432 pi, and we want to represent the h in terms of r. This is the a part. H in terms of r. Okay. So what I will do, the volume of the cylinder. The volume of the cylinder is pi r square h. That is 432 pi. Pi will be gone. So r square h 432. So the h will be equals to 432 divided by the r square. So I just found the h in terms of r. Okay, h in terms of r. Question number 12, 430 by r square. So my answer is right. Okay, now the b part, question number 12, show that the area is equals to 2 pi r square plus 864 pi divided by, this is the b part now which we have to do. Question number 12, b part. We have to show that the area is this. Okay, the area, a solid cylinder. Okay, this word is very important. It's a solid cylinder. It has top, it has bottom, it has sides. Okay, the area, the curved surface area. There are two areas. The top, which is pi r square, the bottom, which is pi r square, the walls 2 pi r h. So the area, the solid cylinder, its area is its top, its bottom, and its walls. The top is pi r square, the bottom is pi r square, and the walls are 2 pi r h. Okay, so in the place of h, I can write this number. So area will be equals to, this is 2 pi r square, okay, plus 2 pi r, and the value of h is 432 r square. So you will have area is equals to 2 pi r square, and this r. So you will have 2 2s are 4, 2 3s are 6, and 2 4s are 8. And you will have pi and divided by the r. Okay. So the area, this is, I think, what we have to show. The area is 2 pi r square, yes, plus 864 pi divided by r. Okay, so this was the b part. We have to show the area is this. Okay, then we have the c part. He says find the value for r for which there is a stationary value of a. So very simple, you have to derivate it. Okay, so first of all, I have to derivate it. dA by the dr will be equals to 2 pi 2r, and this will be 864 pi, and the minus 1 will come on the side. R will have minus 2. Okay, so the friendlier shape is 2 pi r square plus 864 pi and r raised to power minus. Then I derivated it. So dA by the dr is equals to 4 pi r plus, this will become minus, okay, 864 pi divided by the r square. So this is my first derivative. You see, let me check again. We converted this into a friendlier shape, 2 pi r square plus r raised to power minus 1. So I derivated it 2 pi into 2 into r. plus 864 pi and minus 1 and r raised to power minus 2. So it will come 4 pi r minus 864 pi divided by the r square. Okay, so you know that at the stationary point, you see what happens. The dA by the dr is, okay. So you will write here at stationary point, at the stationary point, the dA by the dr is equal to 0. Okay, at the stationary point, the dA by the dr value should be 0 at the stationary point. Okay, so we will make that value 0. So you will have 4 pi r minus 864 pi divided by the r square equals to 0. Okay, so what I can do now is this will become 4 pi r equals to 864 pi divided by the r square. Take this r square here. R cube is equals to pi gone. So 8, 4 2s are 8, 4 1s are, and 4 6s are. So then take the cube root on both the sides. Take the cube root on both the sides. Okay. So then the r value will be, the r will be equals to how much? I think 6. The value of the r will be 6. So at the stationary point, the value of the r, at the stationary point, the value of the r will be 6. So at r equals to 6, I think there will be a stationary point. Then they say, this is the D part. Determine the magnitude and nature of this stationary value. Okay, for finding the nature of this stationary value, we need second derivative. Okay, so what I will do, I will find out the first, and this is my first derivative, dA by dr is equals to this is 4 pi r minus 864 pi and r raised to power minus 2. This is my first derivative. So I will find the second derivative, d square a by the dr square will be equals to, this will be 4 pi minus 864 into minus 2 into r raised to power minus 3. So you will have d square a by the dr square, that is equals to 4 pi minus plus 2 2s are 2 4s are 8, 2 6 are 12, 2 8s are 16, 16 and okay, divided by the r cube. Okay, so then I will put that value of the r here, and then we will see whether the answer is positive or negative. On that basis, we will decide it's a maximum point or a minimum point. The value of the r at the stationary point is 6. Okay, so at r equals to 6, at r equals to 6, okay, let's see what happens with this value. This game of calculator now. 4 pi plus 1728 divided by the 6 and its cube, and this value will be automatically positive, but let me do that. I don't know, I just got a message by chance. I looked at that message, but I was not able to read it. So 4 multiply pi and plus 1728 divided by the 6 cube, 6 and cube. Okay, so the answer is 20.566. So this answer is 20.57. We are not interested in this answer. The basic thing we are interested is that this is a positive thing. Okay, if my second derivative is positive, that means that this is a minimum point. Okay, so the minimum value of the area, the minimum value of the area will be at the value of r equals to 6, and where we have that formula. Okay, so this is the formula for the area, that is 2 pi r square, that is 6 square, plus 864 pi divided by this is 6. So from here I can calculate that minimum value of the area. It's just the calculation. It's now just calculation. Okay, so I can do this calculation, and it says 2 multiply pi multiply 36, okay, plus 864 multiply pi divided by 6 equals to, my answer is 678, and 678, okay. They have not given the answer in the, they have given the answer in the terms of pi. So this is 36, 36 to the 72 pi, plus this is 864 divided by the 6, and that is 144 pi. In the book, they have not, they have given the answer in terms of this, okay? So you will have 6, 7, 4, 11, and 2. So they have given the answer like this, okay? So this will be centimeter square. So this area will be the minimum area. And so we are working on the AS. This is A1. I don't know why it's not clear. I will upload this video, and you will be able to see this. In the live, due to the, the nowadays in Pakistan, the internet is down. So due to that, I think the image is not clear, but when I will upload this live video, and you will be able to see that recording. Okay. So basically we are working, I am working, but why are you teaching this late night? Because I have time at this time. So, so this is basically AS mathematics, which is a part of A levels, the first year of the A level, and it's Maths 9709. So this is not, I just wanted to record this. That's why I'm live. And when I record live, it's easier for me. So that's why I'm doing it live. It's not important that you come into the live session. So the important thing is that you watch the recording. Okay. So basic theme of this video is that see some students whose mathematics skills are weak. They understand the concept when they do a lot of questions, when they do the course book. The students who are very brilliant, the students whose basic mathematics is very good, they don't need to do the course book. They can understand the concepts, and they can just learn the thing. They can master the thing just by practicing the topical. But the weak students, they need to go through the course book, and then they are able to grasp that concept. So I'm working for them. So thank you very much for watching this video and bearing it. You can watch the recording of this thing if you think this video is helpful. If you think this live is helpful, please share the link of this recorded video and the recorded video of the live session, and share it with those students who you think this video can be helpful for them. And also you can share the link of this video on your Facebook. So what happens is that we don't care about the people that much. Okay, so we do what we think is good. Okay, so thank you very much for being a part of this live session and watching these videos. If you are in A levels mathematics and this video is helpful, please share the link of this. Also like my video, and also subscribe my channel. So thank you very much, sir. Have a good day, and God bless you all, sir.